Hello class, Miss Emami here. I hope you're all fine and doing well. Today we are going to have part 1 of our lesson 3 on how the amplitude of a sine or a cosine graph will change by changing some values in its equation. What we call the 5 key points. I've talked about this before, but now it is very important to go and revisit this concept that we are looking at a sine and cosine function, and in order to graph them, there are 5 key points that we have to graph. So it is a pattern that you have to remember, that when we want to graph the sine, you always start from where axis of curve is. Sometimes for the basic function, the axis of curve is the same as x-axis, but I want you to remember that if the axis of curve moves up or down, that means that this point is going to move with the axis of curve. So you always start from axis of curve, then it will reach to the max, then comes back to axis of curve, comes down to minimum, and then back to axis of curve. So this is a pattern you have to remember when you are graphing a sine. Please remember that for a basic sine function, your period is 360. So your period is 360 degrees. So that means these points are at 0, 90, 180, 270 degrees, and 360. So these are the key points that we are going to use when we are graphing a sine function. If we are graphing a cosine function, again, the pattern is a little bit different, and the key points to remember is that we start at the max at 0, then at 90 degrees we go to axis of curve, at 180 we reach the minimum, so this is 180, at 270 we are back to axis of curve, and then at 360 we're back to maximum. So the pattern for graphing a cosine function is max, axis of curve, min, axis of curve, max. And for the basic cosine function, the period is 360 degrees. So these are the points where we are going to hit these values. Now I'm going to ask you to watch a Desmos demo, and see if we multiply our function, our sinusoidal function, by a value. A value, a number is multiplied by sine, how the graph is going to change.
We are going to investigate how our graph of sine x is going to change if we have a number multiplied by the graph, as we call it an a value, or later we'll call it the amplitude. So right now the red graph you see here is the y equals sine x, and as you can see, I am going now to show a second graph, which is y equals a times sin x, and at this point, as you can see here at the left hand side, the value of a is 1. So I'm going to show a, which is the blue graph, which if a is 1 is going to be exactly the same as the red graph. Now I'm going to change the value of a and see how the graph is going to change. So now the value of a is 2. As you can see, the maximum and minimum and the amplitude have doubled, but the shape has not changed, and neither has the period. The period is still 360 degrees. The shape and the pattern is the same, starting from axis of curve going to max, axis of curve, min, axis of curve. The only thing that has changed is the amplitude and max and min. So now if I make it 3, it's going to be tripled and 4 times. Now, what happens if we make this a negative value? So as you can see, when a becomes negative, for example, this a becomes -1, we have a reflection over the x-axis. And if I make it -2, we have a reflection over the x-axis. We also have the amplitude being doubled.
Now you have watched the video, the Desmos demo, and you have realized that if we multiply our sine or cosine function by a value, this value of a shows us if our amplitude is going to have a vertical stretch or a compression. If this number is greater than 1, we are going to have a stretch. If it's less than 1, we are going to have a vertical compression. And if negative, we will have a reflection over x-axis. Which means that if we have our basic sine and cosine function and it is multiplied by a, the amplitude will be equal to a. The period did not change, so the period will stay the same, which is 360, and this did not have any effect on our axis of curve. So axis of curve is still y equals 0, which is our x-axis. So now we are going to do a little bit of practice and try to graph some functions where these transformations are happening. So our first example here is y equals 1/2 sine theta. Right away, this is our a. A is 1/2. So we know that our amplitude is 1/2. Our axis of curve is not changed. So it is y equals 0, and period will not change, so it is 360. Now, in order to find the max and min, is wherever axis of curve is plus the amplitude So your max will be at 1/2, and the min is where axis of curve is minus the amplitude, so min is -1/2. Now if you find it useful, maybe you can add this to your formulas, that max is axis of curve plus amplitude, and min is wherever axis of curve is minus amplitude. Now we are ready to graph. So first I am going to put my x and y axis here. So y. Now here we have theta. So instead of writing here x, because it's not sine of x, I'm going to use actually the simple theta. So make sure that you are consistent. If the angle here is theta, here you are going to have theta as well. Now, so this is 1, -1. So our max and min, max is happening at 1/2, so that's 1/2, and min is going to happen at -1/2, which is here. As I said before, the first thing I want you to do is to draw the axis of curve using dotted lines, so that's what I'm going to do. You are going to label it, it's y equals 0. And now we are ready to draw our sign. We just have to put our key points here. So 0, 90, 180, 270, and 360, because a period has not changed. This is sine. So if you remember, sine pattern says axis of curve, maximum, which is 1/2, axis of curve, minimum, which is -1/2, and axis of curve. So axis of curve, max, axis of curve, min, and axis of curve. And then you are going to label it. So this is going to be your function for y equals 1/2 sine theta. Now, the next example we are going to do here is y equals -2 cosine theta. So, your A is -2. Now, if you remember from the previous lesson, I told you amplitude is always positive. So, amplitude is actually 2. The negative here means that after we draw the function, we have to do reflection over axis of curve. So this negative here only means a reflection. Axis of curve is y equals 0, and the period is 360. Max is axis of curve plus the amplitude, so 0 plus 2 is 2, and min equals 0 minus 2, which is negative 2. So now we are ready to start. Y theta. Now the axis of curve is at y equals 0. So this is y equals 0. The max is at 2. So 1, 2, this is max. And then the min is at negative 2 here. Now we are going to put our key points here. We have 0, 90 degree, 180 degree, 270 degree, and 360 degree. Now the key point here is that because we have to do a reflection, we first will do the 2 cosine theta, because we know what's the cosine pattern, and that has to be reflected. So I do the first one in dotted lines. Okay, so the cosine key points, if you remember, starts from max, goes to axis of curve, goes to minimum, axis of curve, and then goes to max. So I am going to do this with a dotted line. So this one is actually y equals 2 cosine theta. But the question is asking us to do the one which is reflected. So now I'm going to reflect this over the axis of curve. So the reflection of this over this is going to come here. This is on the axis of curve, so it is going to be the same point. This point will go here, this will stay the same, and this point will be reflected here. So our actual final graph is going to look like this, and I am going to label it.